Binary logistic regression with continuous predictor and binary predictor in JAMOVI. Binary logistic regression is a statistical method that can be performed to find out whether there is association between two variables. One of the variable is called outcome, the other is called predictor. The outcome can be also given a name such as response variable, dependent variable. The predictor can be alternatively called independent variable, exposure variable, explanatory variable. So the aim of this test is to find out whether there is a relationship between a predictor and an outcome. And to perform this binary logistic regression, the outcome, which is the dependent variable, have to be binary. Binary variable means that there are two levels in the variable. Whether you are alive or dead, you are having a diabetes, no diabetes, having cancer, no cancer. So this is a binary or binomial variable which has two levels in it. The predictor, on the other hand, can be either a continuous variable. A continuous variable can be measured at a ratio or an interval scale such as temperature, height, weight, and so on. The predictor can be also binary if it has two categories in it, such as gender, male or females. The predictor can be multinomial if it have in it three categories or more, such as occupation, doctor, dentist, scientist. And finally, a predictor can be ordinal. Ordinal variable is categorical variable with an order in it. So the regression test will try to determine whether there is a link between the predictor and the outcome, and whether the variation in the outcome can be explained by the predictor. For building a model for logistic regression, we only need one outcome to be binary and at least one predictor. The predictor can be one predictor or multiple predictor, and the multiple predictor can be a combination, whether one continuous predictor or two continuous predictor, one binary, one categorical, one binary, one ordinal. So predictor can be any of the type of variables. In this JAMOVI datasheet, I had inserted 100 cases and 3 variables here. The first one is the gender. Gender is binary variable because it has two classes in it, males and females. So it is binomial variable. The age is a scale, a continuous variable, as it has years of age for each individual participant. And the third variable is the binary variable, or it is binomial, as it has only either you have the heart diseases or no heart diseases. So there are two categories or classes. So this variable is binary. The age is continuous and the gender is binary. So we have here two predictors, gender and age, and one outcome, which is the heart diseases. So in this situation, we have an outcome that is binary and a predictor that is one is continuous and one is binary. To find out whether there is association between these two predictor and the outcome, and whether the outcome, the possibility or probability of developing heart diseases, can be explained by the two variables, binary and continuous, then the binary logistic regression can be performed, as the outcome here is binary, which is the heart diseases. Before we proceed and do the regression, let's look at some descriptive statistics by clicking on exploration and then select descriptive. Drag the sex into the variables, the age into the variables, and the heart diseases into the variables. And let's tick on the frequency tables here for the variables that have categories in them. The first table shows that there are 3 variables. There are 100 cases, no missing cases. For the sex, it is assigned either 0 for female and 1 for male. So a value of 0 and 1. For the age, as shown here, the minimum is 18 years old and maximum is 94 years old. And the mean and the median and the standard deviation is given here. For the heart diseases, there is no missing cases. Moving to the next table, for the gender, there are 52% females and 48% males. And for the frequencies for heart diseases, 44 cases of no heart diseases and 56 of cases having heart diseases. To do binary logistic regression, click on the icon here, regression, then select the 2 outcomes binomial. In this window, since we already determined that the outcome is the heart diseases as it is binary, then move it to the dependent variable. And the age is a continuous variable, scale variable, move it to the covariate. And the sex is binary, move it to the factors. So we have here 2 predictors and 1 outcome. To select some options from here, drop-in menu, nothing from model builder, but for reference levels, for heart diseases, there are 2 levels in it, no heart diseases and heart diseases. So no heart diseases is assigned as a reference category. For sex, the females are assigned, female group is assigned as a reference category to compare to. Assumption, nothing to check from. Model fit, tick on the Cox and Snell's and the other R square here. For model coefficient, tick on the odds ratio and the 95% confidence interval. For estimated marginal, nothing to choose from. For prediction, nothing to choose from. So looking at the output from the binary logistic regression, the first table is the model fit measures. And looking at this value R square here, it indicates that nearly 81% of the variation in the outcome can be explained by the 2 factors or the 2 variables, the age and the gender. So heart diseases, variation in the heart diseases can be explained by the factor of age and sex. Looking at the second table, model coefficient for heart diseases. Here we are comparing heart diseases to non-heart diseases. The 2 factors or 2 variables are given here for age and sex. For the sex is binary, so males are compared to females since females are the reference category. The coefficient value is given for the 2 factors, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval. 2 levels of or 2 layers of checking significance. The p-value, anything less than 0.05 considered to be significant, and for 95% confidence interval, the odds ratio need to fit between the upper and lower 95% confidence. As shown here from the p-value and the 95% CI, for the age and the sex factor, the p-value is significant. So there is a significant association between the age or the gender and the probability of developing heart diseases. This association is significant, so the 2 predictor, age and sex, can predict the outcome, or the variation in the outcome can be explained by these 2 factors. The way to interpret this findings or this table or this result is that for the age factor, for every unit, 1 unit increase of age, which is 1 year, there is a 1.1 increased likely or increased odds of developing heart diseases. So with increasing age, there is an increased chance or likelihood or probability of developing heart diseases. Controlling for 6. The precise way to describe it is to state that adjusting for or controlling for the 6th factor with an increase of 1 year of age, there is an increase of 1.1 odds of developing heart diseases. Looking at the 2nd factor, which is gender, comparing male to females. Again, the odds ratio is 18.5. So the way to interpret this finding is that controlling for or adjusting for the age factor or variable, males have a higher 18.5 odds of developing heart diseases compared to females. So males are more likely to develop heart diseases than females. In another way, males have 18.5 times higher chances or likelihood of developing heart diseases compared to females. This is the way to perform binary logistic regression with an outcome that is binary and a predictor, more than one predictor that can be a continuous and a binary in JAMOVI. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.